Welcome to myprojectbazaar.com. Our project title is Infill Test for Permanent Faults in FIFO Buffers of NoC routers. Abstract. This brief proposes an online transparent test technique for detection of latent hard faults which develop in a first input first output buffers, that is FIFO buffers of router during field operation of NoC. The technique involves repeating tests periodically to prevent accumulation of faults. A prototype implementation of the proposed test algorithm has been integrated into the router channel interface, and online test has been performed with the synthetic self-similar data traffic. The performance of the NoC after addition of the test circuit has been investigated in terms of throughput, while the area overhead has been studied by synthesizing this test hardware. In addition, an online test technique for the routing logic has been proposed, which considers utilizing the header flits of the data traffic movement in transporting the test patterns. Let us see the flow of our project. First, network on-chip design is done. In that, we have to implement 4x4 mesh topology. The 4x4 mesh topology have 16 nodes which contain source node, neighbor node, and destination node. Input data is passed via that source node. Then we have to assign the source. Then we have to assign SRAM, there is static RAM for all nodes. Then we have to estimate the router. So if the node sends information to the neighbor, the router is estimated by using the cost of the journey. Then FIFO buffer is created, that is nothing but the temporary buffer. When we have two test modes, there is one for normal mode and another for test mode. When we click on this test mode, that is built-in test self-test, we start this built-in self-test. It will check the original data with the fault detection data. Fault data is nothing but if we have given the data as 0, that is 8-bit data, it will complement the data, that is fault data is 0. So we have to check this data is stored in the FIFO buffer, that is temporary buffer. We have to check this data with original data, and we have to identify the fault data in which memory, and we have to reduce the latency and to increase the throughput. Let us see the output of our project. When we implement our in the field test of NoC design, we have to create the code, and this is a code. So after completing the code and this launching IAC test data to edit main.phd is displayed. In that we have to two phases for running the file. First one is implementation and simulation. For simulation, first click on simulation and click on this simulate behavior and model. It will generate our output window. So that window contains the clock, reset, data enable, there is for test mode, and operation, and data file, that is data input file. Then we have to give the RAM position where we stored in RAM also is edited. So this is our output window. In that we have to give clock. Then give reset. Then go address. Then we have to first give one for disable disable the write operation. if we enable anything, give the constant as 1, as 0. 1, and this is for selection line. This is nothing but the cost. Which path is, if the source have the 3 neighborhood, it select only one node. So give any, then give data input. Okay, when we run this using this run for the time specified on the toolbar icon. So when we if reset is 0, it will start the process. So we give 0 as this input reset button. So now we have to enable our write operation. So give 0. If we give the 0 in our write operation, then the data D in what all the data in D in is passed through the neighbor nodes. So now P0, P1 is received the information and it is passed through the neighbor nodes using the network interface. So when we enable this open enabler, it will send the information to that destination. Data out. So data out now receive the information. So if you enable this as 0, it will start to testing mode, that is best is done. So now the data is undefined, that is the fault node is entered into the process and it will change, that is our out input is 0 0 0 0. Then the fault node is identified, that is which change the input to the complement manner. So we have to identify this and we have to checking process is done in this place. So data in is not equal to 0 1, that is the fault node. So we have to produce out the skew. 1 is nothing but the our process contain error, that is fault node. We have to identify that fault node. For implementation, click on this, then click view RTL schematic. This in that add button, click router our process name, it will create our coding, whatever even the coding is displayed in the diagram. We do not want to draw this diagram, it is automatically generated depending upon the coding. So this is our RTL diagram for running our designing summary. It is how many flip-flops are used and LUTs are used is displayed in this place. So this is our number of flip-flops. We have to use less amount of flip-flops, LUTs than existing system. We have to reduce all the things. Also we have to reduce the time delay and the minimum periods and the clock arrival time.